super excited about. Chris Penn. I've done AI in my life before. As Chris has educated me, there are AI summers and winters, and we are in the summer, and I was working on this in the last summer. So I can tell you for a fact, there's very few people who know this particular topic and applicability to that, especially in marketing and Chris Penn. So he's the chief data scientist at Trust Insights. They are a data detective firm for performance marketing leaders. He is definitely a recognized thought leader, serial best-selling author, and a keynote speaker, and recently published the book AI for Marketers, which I would highly check out. I would also, in my humble opinion, he also has an amazing newsletter that's always chock full of great topics, resources, references. So if you're trying to get up to speed on anything AI marketing related, AI data marketing related, and some extra wisdom about everything that's going on in MarTech, please do go sign up. I'm not supposed to endorse that, but I am now. So he has a deep eclectic experience in a variety of industries, and I will also be looking to Chris as savior from Skynet when customer judgment day comes around. So I'm looking forward to hearing his 5 examples on AI data marketing, and we should hear some great actual insights and some toolbox opportunities as a result of boosting our marketing performance. So with that said, I welcome Chris to the stage.
Thank you very much. Thank you, sir. All right, good morning, everyone. Let's get started. Should you want to get the slides, the video, and the audio recording, you can get it at the aptly named wherecanIgettheslides.com. We have a problem. We have 3 problems. Our customers, our board members, our CEOs all demand the same 3 things: better, faster, and cheaper. As marketers, how are we doing with this? Let's take a look at better first. In the 2019 Price Waterhouse CEO survey, CEOs were asked, what are the things that matter? CEOs said data about our customers and clients' preferences and needs. 94% of CEOs said this is essential. Right? Data about your brand and reputation, data about your employees' views, data about your industry peers. And then when you look at what CEOs say, are we getting this data? The answer is 15% of CEOs feel like they're getting data about the customers and clients' needs. So clearly, we're not really doing better. When you look at the CMO survey, which you can get at cmosurvey.org, released twice a year by Duke University, CMOs were asked, how are we doing with integrating customer information? And it is a lovely flat line, the death of marketing. When we look at all the shiny objects in marketing, social media, digital, mobile, all the app economy, and you look at what contributes to marketing performance, it's actually analytics contributes more to company performance than any of the shiny objects. And yet as marketers, we spend all of our time on the shiny objects. And when we look at how are marketers using data, marketers are using data less now than they were just 6 months ago. Only 39% of marketers use data to make decisions, which means that the other 61%, I guess, are just guessing and making stuff up. So we're not better. Are we getting faster? Are we as marketers getting faster, staying with the times? In 2019, this year, we as a civilization are going to create around 45-ish zettabytes of data, according to IDC. A zettabyte is an unimaginably large number. Just to give you a sense, if you were to start watching Netflix and you didn't stop to eat, to sleep, to use the restroom, or anything else, and you started 55 million years ago, you'd be just getting to 1 zettabyte today, and we're going to create about 45 of these this year. That's how much data there is. And it's going to explode by about 5 times in the next 5 years. Why? All these lovely devices that we're wearing are capturing data. This room is filled with sensors. All of you are wearing multiple sensors right now. Even your phone has like 6 sensors. All of that data is available to us. We're not using it. When you look at what happens in an internet minute, right? In 2018, in 1 minute on the internet, people watched 266,000 hours of Netflix. This year, 694,000 hours. That is a ridiculous amount of Netflix and chill. Right? When you look at the spending online, the number of searches, everything is going up. Even Tinder swipes go from 1.1 million last year to 1.4 million this year. I'm guessing mostly right because of the increase in numbers on Netflix. We have so much more data, and it's coming at us so much faster. When you look at the number of news stories every year, this year we're on track for 122 million news stories, just news stories. That's about 178 a minute. If your company is on the front page of the New York Times, you're gone in 8 seconds, right? Because there's another news story. So we're not getting faster. We're at least getting cheaper though, right? Things are getting more cost efficient, marketing spending less. No. Marketing spending record levels on training and development. Marketing spending more on products and services. Marketing budget is consuming more of the firm's budget than ever before. Yet, if you go to the other side of the house and you ask the CEOs what's important to you, number one on the chart is operational efficiencies, which is code for budget cuts. Right? So we're spending more, and the CEOs are saying spending less. How's that going to work out for us? Not great. Right? So we're not better, we're not faster, we're not cheaper, we're probably fired. The answer to this, or an answer to this, unsurprisingly, is artificial intelligence, machine learning, which promises us 3 basic things: acceleration, accuracy, and automation, also known as better, faster, and cheaper. Machines are much faster than we are. Computation, it's just a fundamental truth. Our brains are actually the most sophisticated neural network computers, but we're really, really slow. We are not accurate. Anyone who's ever copied and pasted something wrong knows we're not terribly accurate. And how many of you have at least one task a week that you just don't love doing? Right? Pretty much everybody. If you didn't raise your hand, then you're lying. So we have all these tasks we want to get rid of. What is this stuff? What is AI? The snarky commentary in the data science community is that if it's a machine learning code, it's AI. That's machine learning. If it's on a PowerPoint, it's AI, because people love to apply the label to everything. Fundamentally, artificial intelligence is about mapping human capabilities to machines, getting machines to perform the same tasks of intelligence that human beings can do. All AI begins with stats and probability. Right? AI is math, not magic. If you were to make, say, let's use an analogy like making pancakes, right? The fundamental building blocks of pancakes are based on raw ingredients. The fundamental building blocks of AI, stats and probability, math and data. From there, we move up sort of in maturity to algorithms, right? Algorithms are just processes with known outcomes. We've been using them forever, right? A/B split tests are algorithms. You have an algorithm. Right? I guarantee you probably put on the same general article of clothing every day in the morning, right? Some people put the top on first, some people put the bottom on first, a few weirdos put their socks on first, but it's the same. It's an algorithm, right? In our pancake analogy, it's a recipe, right? We have a recipe. That is an algorithm with a known outcome. Where things change is now, instead of us writing the algorithms, we have machines learn to write algorithms based on data we give them, right? So we have our machines, and we try to teach our machines to recognize and learn from pancake making, right? From patterns. So there's 2 branches of machine learning. One is called supervised learning, where we have an outcome we want the machine to learn. So if I take 1,000,000 pancakes and show it to a machine, it starts to recognize this is sort of a pancake, right? It's round, it's flat, it's kind of cooked on the outside. Then we try and get the machine to make pancakes. And in the beginning, it does terribly, right? It throws the pan across the room, lights everything on fire. But after it trains and learns enough with supervised learning, it can eventually make pancakes. And then it can make a lot of pancakes. The most famous example of supervised learning comes from 2013. IBM's oncology division used Watson at the University of Tokyo to treat a case of leukemia. A woman had leukemia. She was not responding to treatments. And they tried everything. She didn't get better. And so they took her genome and sequenced it and fed it to Watson, and then took 233,000 oncology journals, fed that to Watson, and said, figure out what's wrong. We know the outcome we're after. Figure out what we're doing wrong. Watson spit back, you're treating the wrong kind of leukemia. Right? You misidentified it. You misdiagnosed it. They changed the treatment. She made a full recovery. That's pretty cool. What's even cooler is Watson did it in 11 minutes. Right? That's the power of really good supervised learning. The second branch is unsupervised learning. When you have a whole bunch of data, you're like, I don't know what to do with this, right? In the pancake analogy, put a whole bunch of foods in front of a machine and have it categorize and classify them. And by the way, none of these things are pancakes, apparently. I don't know what I was cooking that day. But you have all the stuff you just need to classify. We are surrounded by data that we need to classify before we can make use of it, right? I was running late for a staff meeting, and I needed to present to the client what 2,600 articles about them were about. What were the topics? So using unsupervised learning, a technique called text mining, we're able to create a topic model that turned those articles into one chart that I could walk the client through and say, here's what the articles were mostly about. And I was able to make the meeting, actually had enough time to make coffee. The last iteration currently of machine learning is this idea of deep learning. And deep learning is when you take all these layers of machine learning, stack them together, chain them together, the data flows from one to the next, and you get outcomes that are better, faster, and cheaper than we are. You see this with things like self-driving cars today, right? That is an example of deep learning, where the networks of computers can do a much better job of driving than we can, especially that one person I drove by this morning who was like putting on their makeup and drinking coffee and reading a paper, and I don't know what they were steering with. So that's the sort of the hierarchy of AI today. Stats and probability lead to algorithms, leads to machine learning, leads to deep learning. Now, why do you need to know this, right? Some of you are coders, most of you are not. You need to know this because when you go to the expo hall, or you've been to the expo hall, you need a finely tuned detector of what our Spanish friends would call excremento de toro. Every vendor in that hall says they have AI in their product. Some of them are lying. In 2018, the Financial Times did an assessment of AI companies and found 35% were completely lying, had zero AI in their product whatsoever. So you need to know the lingo, at least somewhat, to be able to call BS. I was at the Pointillist booth. By the way, if you are exhibiting at a technology show and you fail to bring an engineer to your booth, go home because you're doing it wrong. I talked to the Pointillist engineer and he was like, okay, so we're using gradient boosted trees here, we're using GLMs here, we're using XGBoost here. I'm like, okay, you know what you're doing, which is nice to be able to talk to the people and identify. This vendor knows what they're doing. So you need to build this vocabulary so that you can ask a vendor, okay, you say you have AI, what kind? I'll get it. All right, we're going to disregard the fire alarm test. The state of the art in machine learning and AI today looks like this. In February of this year, IBM did a thing called Project Debater. They put a human debate champion on stage and Project Debater, and they gave them 15 minutes advance warning of the topic. Should we subsidize kindergarten? Both contenders had to come up with arguments. They delivered their arguments on stage. They rebutted each other's arguments out live and then delivered closing statements. And the machine did a very credible job. It was a combination of deep neural networks and expert systems training. Now imagine that in your marketing. If you had a machine that could have a coherent conversation with a customer on the phone and not say something obnoxious to them. That's the power of what this technology can do today. Here's what it can't do. Machines are bad at empathy. We define empathy as knowing what someone's experiencing and then acting on it. Machines can't do that. Machines are bad at judgment. We mean judgment here to say going outside the rules. You ever been to a restaurant and you greet the server like pleasantly, like they're an actual human being, and they're like stunned that you're treating them nicely, and they bring you an extra appetizer, right? That is judgment, human judgment, going outside the rules. By default, the machines are the rules, so they cannot exercise judgment. Machines are bad at life experience, at cross domains. They're very good in one specific task right now, but they cannot cross domains. And for the most part, most people prefer to have human-to-human relationships in business. The exception is if your customer experience is so awful that a machine is better. For those of you who are not from America, in America we have this organization. It's called the Department of Motor Vehicles. Nobody wants to deal with them. We would all prefer if they were all machines, right? But that's what AI can't do. So let's talk about how we're using it now, how you should be using it today in marketing. There's a whole bunch of use cases in the CMO survey, but I thought we'd focus on some of the practical ones, some of the things that you could do with data scientists and machine learning engineers on your teams today. There's 5 problems. Number 1, you have a whole bunch of data and you don't know what's working and what's not. Right? That's one problem that we can address. You don't know what things like in your content marketing, what should be your priorities. You make all this content, what do we do with it? A third problem, you have data and you haven't mined it. You haven't taken advantage of it, right? You've got those zettabytes of data, and you're not doing anything with them. Fourth, because you can't predict and forecast, you're constantly running around with your head cut off. Right? If you ever listen to somebody on the social media team or the content marketing team saying, we don't know what we're going to do this week, that's an example of a failure to plan. And fifth, when it comes to things especially like influencer marketing or key customer marketing, you don't know who you can reach. So those are the 5 problems that AI can address. Let's unpack each of these. First, unfocused. If you use machine learning and data you already have from either Omniture or Google Analytics, you can build what's called a digital customer journey that shows you the impact of every single channel on conversion, whether it's the last thing somebody did, the first thing somebody did, or somewhere in the middle. And when you sequence that data out by time, you can look at your channels and say, now I know what to message. Right now I know if Twitter is at the end of my customer journey, but I'm saying, hey, get to know us, that's a clear message mismatch. Same as if you're on YouTube and you're saying, hey, you should buy this thing right now. And people are like, who the heck are you? Right? That is a messaging mismatch. So this is a technique called Markov chain modeling. Using that with the existing data you already have, you can build digital customer journeys and understand what drives conversion and how to pivot to your strategy. So you set your strategy with this. You can even set budgets with this. And if you have the technology in-house, if you build it yourself, you can run this whenever you want. You can do custom lead scoring without a black box, meaning this is an example from IBM Watson Studio. No coding involved. You just drag and drop the components you want from your data. Like I took my data out of HubSpot, of our HubSpot instance, and I said I wanted to build a lead scoring mechanism that tells me what things make a valuable lead. Right? So I pull in the data, I drag and drop the pieces I want, tie them together with those little strings, and then it spits out lead scores that I can put back into HubSpot and understand what leads are really important. Right? This is using the same thing, driver analysis, multiple regression. Second application, you don't know what content is priority. Again, using similar techniques like gradient boosting, you can look at every page on your website and see how it leads to conversion. There's an apocryphal tale of a college that didn't pave sidewalks when it first opened a new campus. It waited a year, looked at where the students walked, and then paved sidewalks where the holes were worn in the grass. It's apocryphal because no one can figure out exactly who actually did that, but the idea rings true for your marketing. When people walk page by page through your website towards the goal that you want them to reach, can you track their paths and understand, like this page on the website always seems to nudge people towards conversion? Using, again, Markov chain modeling, you can identify what pages convert most and then take that data, feature it in your email newsletter, run social media ads on it, put it in your recommender system. You ever go to a blog and it says at the bottom, you might also enjoy these pages that seem to have nothing to do with what you're reading, but they help drive conversion. So it's an example of using machine learning to bolster your conversion rate optimization. A third example, in SEO. SEO can be an incredibly complex system to untangle because there's so many numbers and so many metrics. Which ones actually matter? Using simple clustering techniques like k-means clustering and k-nearest neighbor, you can identify the pages on your website that you rank for, but you're not strong enough for. And you fix those pages, tune them up, add new content to protect the traffic and the rankings you already have, and then do the same thing to your competitors. Look at all their data, cluster, rank, order, and then figure out these are the pages where there's a lot of search volume, but our competitors are weak. We can take market share away from them. It's an incredible way to steal traffic from a competitor on pages they're not paying attention to. So this is, again, using some very simple, straightforward statistical techniques and a bit of machine learning to identify how to take away market share from a customer. Third application, you have data. You have a lot of data. How do you use more of it? So far, as of 7 a.m. this morning, we collectively have written about 29,000 words about MarTech on the MarTech hashtag. Right? That's basically a novel. How many people have had time to read a novel in the last day? Not me, right? But if you use a technique called text mining, you can go from very simple word clouds, which don't lend a whole lot of insight, right? You can see the hashtag. Using text mining and topic modeling, you can pull out just the things that occur the most that people in their language, in the words they use around, say these are the most important things. So like agile marketing organizations, embedded technology solutions, top marketing leaders. This technique can rapidly reduce down a lot of text. We did this for International Women's Day this year. We took the 1.6 million conversations that were occurring, digested it down to one chart and said, do we have, as a company, anything to add to the conversation? We looked at it. We said, nope. So we shut up and we let the day go by because there was nothing to contribute. Easy way to prevent brand mistakes. Another example, a recruiting company asked us to help them figure out why applications were down. So we took their 5,000 jobs from Indeed.com they had posted, and we digested all of the words down. What are the words and phrases that they were using? Class driver's licenses, ages and stuff. And then we took 17,000 phone calls from their call center, used AI to transcribe them, and looked at the words that candidates used with recruiters. Pay cents per mile, starting cents per mile, what type of truck, how much home time, signing bonuses, are you home on the weekends? Now think about that. On one hand, you have all this language over here about licenses and permissions, and on the other hand, you have things like pay and vacation. The recruiting company was saying nothing in their job ads that candidates wanted to hear about. So of course their applications were down. When they changed their language to at least include some of what candidates actually cared about, they did better. Do the same with your marketing. What does your audience talk about with your customer service department? Then look at what's on your website. Are you using the same language or not? Right? If you're not, I suggest that you run this analysis and change to talk about the things that your customers actually care about. Fourth problem, forecasting and prediction. Search data is some of the most valuable data you can have because someone will type into Google things they would never ask out loud. There's a fantastic book called Everybody Lies about the things people type into Google. People will type words and phrases about your industry into Google, and you can extract that data from services like Google Trends and all of your popular SEO tools. But then you can run forecasts using machine learning to look at when in the next 52 weeks will someone search for that term the most. Then you plan your content around that. You do timing, resourcing, ad budgets, social media posts. This is an example from on content marketing when people are going to be talking about certain terms. The first week of this month, which was a couple weeks ago, content marketing template was the most searched term. Coming up at the end of October, what is content strategy? So if I was a SEO company or a consultancy, you better believe that I should be writing articles titled, "What is SEO strategy?" now so that I'm ready for when customers ask the same question. And this works for pretty much any industry where people use a search engine, right? From pharmaceutical, which actually is one of the best applications because of all the restrictions on ads, to truck driving, to conferences, you name it, you can forecast people's behavior. And a lot of the time, it's really, really predictable. You can even digest it down and turn it into a very simple template that you just hand to your team or whatever, and they now have a working plan for what they need to be doing for the next few weeks to get it ready for what customers will be asking about, right? You could even do things like planning call center staffing if you know that your brand is going to be searched for in a non-positive light in the next few weeks. So the fifth problem that you can tackle with machine learning is identifying things like influencers. For good or ill, influencer marketing is literally the most interesting thing to marketers these days. Most influencer marketing tools suck. And the reason they suck is they look at who's got the biggest mouth, right? You could sit at your phone right now and tweet 10,000 times, and in your average tool, that you would be the most influential person, even if nobody paid attention. You could be shouting into the air. If you change how you think about it and say who is most talked about, that's a much better measure of influence, right? So using a technique called network graphing, this is, again, as of 7 a.m. this morning, looking at who has been most talked about at MarTech so far, right? The conference itself, of course, Scott Brinker. We have Matt LeMay from yesterday. You have some of the other speakers, but you can judge who is influential and work with them because chances are they are going to be in a position, say on stage, to recommend your products and services. You can also find new and interesting people who are 1 degree away from the big nodes and say, these are people who might influence the people we care about. And the nice thing about these network graphs is they digest very well down into spreadsheets that you can hand to your PR agency, your ad agency, your social media agency, and let them do the work of doing the outreach, but you have done the homework with data to back up your claims. So those are the 5 major problems and machine learning technologies that help you answer these questions, that solve these problems for you. Why, where, what, when, and who. If you use machine learning technology, you can scale significantly more than the humans you have employed. My company is a 3-person company, but we can do the work of 30 people because we're using machines for a lot of the heavy lifting. The most important thing you can take away from this talk is to start now. You must get started today. Remember, machine learning is all about giving data to machines to learn from. The sooner you start, the sooner you have the data. The longer you wait, the more time you have to then play catch up in getting data to train the machines. So how do we get started? There's a 7-step journey towards becoming AI enabled. The first step is you got to have your data. Right? If you don't have the data, you can't do machine learning. And this is where 90% of companies, their AI efforts begin and end, because they realize everything's in a silo, everything's locked away, departments don't want to play with each other, they have vendors that are uncooperative. Have to solve this first. And if you solve this first, by the way, this solves a ton of other business problems. You then have to become measurement driven, being data driven, which means you make decisions with data first. If you hear, I would say 3 times in a week, if you hear, well, this is the way we've always done it, you should update your LinkedIn profile because that company is dead. Right? Being data driven, identifying your KPIs, working towards your KPIs. A KPI, by the way, is really simple. It's a number that you either get a bonus for or you get fired for. That's it. Everything else is a metric. After that, you need qualitative capabilities. No matter how good the AI is, it cannot reach into somebody's head today and say, why did you do that? Right? Maybe when Elon Musk installs Neuralink in all our heads, we'll be able to do that. But until that happens, we need survey and research and qualitative capabilities to answer the question of why did something happen. The 4th step is process automation. Good old-fashioned process automation, call it business transformation and whatever, but you need time and money and resources to do AI well. It is a profession, right? All these jokers who are taking like the 6-week crash course in data science, it's like I wouldn't go to somebody who took a 6-week crash course in surgery. You need time and resources to do data science well and AI well. So you need to free that up doing process automation. The next 3 steps will depend on your use case of AI. If you just want the efficiencies, these are things you'll look for from your vendors. If you're going to apply it to your core competency, you will need to have these. The first is data science capabilities. You need to have the ability to do data detective work, to answer questions, to explore data, to find anomalies so that you can create valid models. Then, once you have solved those mysteries, you build machine learning models. A model is fancy words for software. So machine learning is still software development. So you need to have robust processes for doing software development where the machines are writing the code. And the destination is an AI-first company where you start thinking, can we apply machine learning to solve this problem? Can we apply AI to solve this problem? If you're like, oh crap, I'm behind, there's only like 5 or 6 companies in that top bracket on the planet, and you know most of them, right? Facebook, Microsoft, Amazon, Google, IBM. These are the companies that have figured out how to put AI as the first thing in a process. The rest of us are trying to catch up to there. To the question of should you buy or build artificial intelligence, it comes down to time, money, and strategy. If you have time and you don't have money, you're building it. If you have money and you don't have time, you're buying it. And if it's something that you're not going to apply to your core competency, just go ahead and buy it from a vendor. It's going to save you a lot of time. If you buy it, the good news is there are so many companies that are adding AI features and have good point solutions that you can find stuff to try really easily, kind of what Scott was talking about in yesterday's keynote. There's a lot of just try it out and see if it works for you. This is a service called otter.ai, and what they do is they take audio and transcribe it. I use this for every meeting I'm in because I can never remember what I've said. I'm recording myself with another microphone right now because I will not remember what I've said, but I can have a machine transcribe it, and then guess what? Now you have content for blogs, emails, newsletters, your next book, all from what you're doing anyway, which is talking. Your vendors are including AI, whether or not you want it. This is Google Analytics. You'll notice in the upper right-hand corner is this Insights button. That is their anomaly detection. It looks at your data and says, hey, this happened yesterday. Do you want to do something about it? So even if you don't plan to use AI, it will happen into the most popular services that you use anyway. If you build it, the system that I recommend using, full disclosure, we're an IBM business partner, is Watson Studio because it offers AI development capabilities for most skill levels. The languages you will need to reach sort of the top stage of AI are R or Python. These are the 2 programming languages that you need to have capabilities in if you're going to build it yourself. How much should you plan to spend on data science and AI? I was talking to someone who presented yesterday. They said in their company, 25 cents on the dollar, right? Out of their marketing budget, they spend 25% of it on data, analytics, machine learning, and AI. That's a good benchmark for how much you should plan to spend on this. It is not cheap. It is not easy. It is not a button you push. But if you do it well, the returns on investment are exponential. So how do you get your company ready for AI? You're going to need 3 kinds of people. I love the expression data is the new oil because crude oil is disgusting stuff. It's useless, right? You need developers to extract the data from all the places it lives in your company and get it into a common system. You need data scientists who can then take that extracted data and refine it, just as you would refine oil. By the way, if anyone's curious, this is the formula for social media influence. It's called inference adoption probability. Who doesn't love math? And most important to everyone in this room, you need marketing technologists to take those refined insights and deploy them, productize them, roll them out in your company. You need all 3 of these roles in a company to do AI well, because data unused or insights unused are useless. If you are a big company, you get these people in this order. Developers first, then data scientists, then marketing technologists. Big meaning Fortune 1000. If you are a smaller company, you go in reverse order. Because as we all know, as marketing technologists, we can find a lot of incremental gains and additional revenue to pay for these other roles. Data scientists are not cheap. A good data scientist that's qualified is going to start you $300,000 to $500,000 a year, right? 7 in the Valley. So you need to find the revenue to support that. Now the question everybody wants to know, will I have a job? The good news is this. The Brookings Institute said this very well. AI takes away tasks, not jobs. Now, if your job is one task, bad news, you probably will lose that job to a machine, but it takes away tasks. So our jobs will change from being the first violin to being the conductor of the orchestra, right? And the machines are doing the heavy lifting. To further insulate yourself, you need to have a bunch of things. One is multidisciplinary skills. Remember, we talked, machines are bad at life experience. They're bad at crossing domains. When you look at the skills that LinkedIn says are the most valuable, you will find a lot of AI in each of these areas individually. But if you are good at sales, and you're good at video, and you're good at people management, you are very difficult to replace because you have cross-domain experience, right? So that's one of the steps you need to take in your career. Second, you need to think like a machine, algorithmic thinking. It doesn't mean becoming a programmer, but it means when you're faced with a problem, especially a repeatable problem, how do you build a system to solve the problem forever? Should be the first thing you think about. Not, how do I solve this to get it off my to-do list today, and this problem will be back next Monday, right? Think like a machine to solve problems. Third, we need to oversee our machines. Remember, AI is math, it's not magic. It doesn't understand anything other than what we put in it, which means that we can introduce incredible biases and unfairness into the system. In 2016, a police department in Florida tried to build a predictive algorithm about which criminals would re-offend, something called recidivism. Their algorithm was 20% right, which is substantially less than the flip of a coin. But it predicted that African Americans would re-offend 5 times more than they actually did. The data went in, was biased, ended up with a biased result. Last year, Amazon created a tool to help with hiring and stopped hiring women immediately because they trained it with data with almost all men. They should have seen that one coming. So we have to oversee the machines and ensure that the outputs that we're getting from the machines are fair, are just, are appropriate. We also have to give some serious thought about what our capabilities are. You've seen things like deep fakes, the ability to map one person's face onto another, and voice synthesis. We, in technology, have a tendency to race ahead, but the famous quote from Jurassic Park is, we're so preoccupied with whether we could, we don't stop to think of whether we should. Ethics in AI is going to be a profession. It already is a profession, but it's going to be a much larger profession in the next 5 years, the more we roll out these systems. And finally, we need to be outcome focused, to focus on what we want, to be the chief questions officer, right? This is a project I was working on. I was trying to learn Keras, which is a deep learning framework. And I was writing code, and I had gotten just to this first column. And I went to IBM Think, and they said, why are you doing that? We have a drag and drop interface. I've spent 9 months trying to learn this. And they said, no, just drag and drop. As long as you know what the pieces do, it'll do it for you. I was like, well, shit. So the machines will do the work for you. This coming year, They said, this past year I went and they said, well, no, that's old news. Now just drop the data in and the machine will do the whole thing for you. And now you just have to inspect the output to figure out whether this is actually what you want or not. All right, so be outcome focused. Now, where's all this going? Machines are creative today. Thanks to some of the most advanced text models, machines can write. They can do incredible tasks. This is an example. I took a bunch of questions from a Twitter chat, and I fed it to a system called GPT-2, and I said, write me new questions that have never been seen before about, in this case, about content marketing. And it created questions like, is having to manually fill out surveys especially bothersome when you can opt out? If you could do one thing about pandering to just one demographic, what would it be? Does having limited visibility on social media affect your work environment? These are coherent questions, right? And oh, by the way, I wrote 20,000 of them, right? So the machines can write, they can create. I'm a terrible artist, right? This is one of my wonderful creations, right? That looks fantastic. But with a technique called generative adversarial networks, NVIDIA will let you take this and turn it into this. It does the drawing and painting for you, turning it to photorealistic landscapes. This is incredibly inspirational to me because it now means that as human beings, yes, some jobs are going to go away and a lot of tasks are going to go away, but this unlocks our capabilities because our limits now are our ambitions. I can't paint, but the machine can paint. So I can express myself and have it come out coherent. I can't play an instrument, but a machine can compose a symphony. And so now I could compose a symphony if I wanted to. So our future, where things are going, is one of limitless possibilities. My friend Laura Gassner-Otting's phrase. Because these machines take the talent out of the equation, it's just what we want to create. So that's our future. That's your future, right? What will you do when the machines can help you do it? Thank you very much.
Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.